So thank you for joining. This is the Oracle Machine Learning Office Hours. I'm Marco Sarancibia. And today with us, we have Mark Hornick and Charla Monica supporting us. So today's session is OML Feature Highlights, a new Oracle Machine Learning templates for machine learning feature extraction for text. Okay. So this is a follow-along session. So hopefully you guys are going to be able to follow and then work your way through the demos that I'm going to do. All right. First, a quick touch on upcoming sessions, and then we're going to go the follow-along sessions on the different demos that we have, and then I'll open for Q&A. So the series that we've been working on so far, we have done all the classification, regression, clustering, and feature extraction number 1, which was the dimensionality reduction. This session is a feature extraction number 2. We're going to talk today about explicit semantic analysis for text. And then we still have one session to go for the complete series with the time series analysis. And on 29th of March, we're going to do a session on how to connect the autonomous database using the new OML4Py universal client. That's something that is coming up in the next weeks. Mark, maybe you have an update in terms of dates that you can share.
Yeah, in terms of the universal client, it's finishing up documentation, and so we plan to be releasing that within, I'd say, the next 10 days. So look forward to that.
Excellent. All right, so let's go then. Basically, feature extraction, right? We looked at the feature extraction algorithms, and we talked about, the MDL algorithm, right? Principal component analysis, the SVD, NMF. Expectation maximization clustering, right? And then the COR matrix decomposition as well. But today's topic is really more on the text side. So we're going to be talking about explicit semantic analysis for NLP, basically, and information retrieval, right? So for that, the idea on the explicit semantic analysis is it is a more interpretable model than the latent Dirichlet allocation, which is the one of the most famous methods for text analytics, right, in NLP. And the idea here is that the word is represented, right, as a column vector, right? You have a term frequency inverse document frequency matrix, and when you convert and create that matrix, basically you're able to map the words to similar concepts. And then you are able to see whether those things are a good fit, right? Or they are very well frequently used in text together and things along those lines, right? So normally what people do, right, and use is the English Wikipedia, right, very commonly. So what we have done on the OML side is we have worked on exactly that, and we're going to show you guys today. And how that gets used, right, and prepared. So the idea is that computes the semantic relatedness, right? So you can see how related are topics or a phrase with a text or a text with, a very large corpus of text, right, or a book. So that's the main idea, right? It's computing that kind of distance, right? So there are a few, more details here, and I'll leave them here for you guys to read later, because you can read these slides. I'm going to share the slides later, so you guys can have, more ideas on what exactly is happening, right, between the ESA and LDA. But the ESA in particular, right, it's going to be, as I mentioned before, creating the map, right, creating a map of words and concepts. So again, Wikipedia is very good just because there are so many articles there about anything you can imagine, right? But there are things that might be more custom or domain specific, then you might not want to use Wikipedia, right? So the idea is that normally companies have their own specific set of documents or types of documents or domain specific articles, right, that you want to relate, and then if you actually add Wikipedia to that or put Wikipedia to try to find these things, then what happens is the concept might be too expanded or too widened, right? So the words that you expected in the medical field might also relate to something else, right? Mechanical or whatever, and then you end up with a confusion there. So it really depends. You have to be careful on what kind of knowledge base you're going to use, right? So for Oracle, what we did is we took the Wikipedia data, okay, and there is a blog about it. So Shari wrote a blog about exactly where we, what do we do, but and where we catch and get those Wikipedia dumps, right? But we take Wikipedia dumps, we process that text, we check, the specific context, right? We then do page filtering. So we page filterings to things that are concept and more general knowledge subjects. So a lot of the stripping, strip out parts of the HTML and components that are not, characters on indexing or numbers that are connecting to something, right? Some topics. And then we go and do a category and article process. So we have a doc store processor that's part of the Oracle Labs. So basically we're removing non-usable information out of that Wikipedia XML. And then finally we build our own ESA model, okay? So we use the ESA machine learning algorithm that we have. And then that's basically what we end up with, right? So the final model is built, and there's around 161,000 topics. And normally the top 1,000 features, right, is what we export. But this is around 27 million records and 100 megabytes in size, right, around 800 megabytes. So that is a big model, right? And what we do with that model is we allow people to use it, right? So we share with you guys for free. So if you guys have an Oracle database, if you have already Oracle Machine Learning for free, and if you're interested in using that model, you can just go and download it, okay? So here is the location. If you go to that page today, right, oss.oracle.com/machine-learning, this is what you're going to see. So you're actually going to see one more, right? This is the older version. I was showing you here the release 12C. If you go today to that page, this is what you're going to see actually. So you got the release 19C, okay? So you can just see the blog and on how to install it, and then you can download it. Okay, it's a big zip file you can download. All right, so but then what's the idea? So we're gonna go now and take a look at ESA in general, right? So first we're gonna go and look at the examples, right? So you know that we have the example notebook. So we're gonna go into the example notebooks. We're going to figure out the ESA ones, right? We're going to see that we have on the left, we have the feature extraction using ESA. Then we have an OML4Py feature extraction using ESA wiki model. And then on the right, we have the OML4SQL feature extraction using the wiki model, okay? So we're going to start with the simpler one, the one on the left, which is just an exercise for you guys to have an idea of what these models are doing. And then we're going to move into the wiki models one, okay? So basically we're going to click here, and then we're going to do create notebook, and then we're going to check the name. The name of the notebook is going to be, we're going to use a default, right? And then when we do create notebook, we're going to see it listed in our set of notebooks. All right. All right, so before I go into the demo, we would like to run some polls for you guys. So if you guys would be nice enough to answer. Sherry, can we start the polls? All right, guys. So this is important for us, right? Because we want to know your opinion, right? What are the kinds of, future office hours that you would like to see, right? What kind of things are the components that you like to see the most, right?
So it looks like we're getting a good 2/3 of folks are interested in the machine learning concepts, basics, ML 101, 102. About 50% for the hands-on labs. Again, about 2/3 for getting started with OML components. And more than a third are interested in upcoming releases and features. And we have somebody who has something else in mind. So if they could add that to the chat or to the Q&A, we'll be happy to take a look at that.
Excellent. All right. Perfect. Thank you, guys. And then the second poll that we would like to ask you guys more specific questions. Thank you, Sherry. So for this one, we'd like to see a little more details, right, into different topics that we have.
So we're looking at scheduling notebooks for model building and data scoring using the OML4Py from OCI Data Science and the new standalone client. There's also working with wide data, columns more than 1,000 that you might want to import into the database and use for machine learning, as well as embedded Python execution, the new SQL API. So I think we're pretty well balanced. I think people seem to like all of those more or less across. So we'll be scheduling those and others in the months ahead.
Right, excellent. All right, guys, thank you very much. It was a great participation. So let's go to the live demo then, and then we're going to open up for Q&A. So this is where I am now, right? So what I am now here is we got our OML, right? So I'm in OML. If you guys are going to follow along, right, then basically that's what I'm doing. I logged in into my Oracle Machine Learning. And right now I don't have any notebooks, right? So what I'm going to do then is I'm going to just click here, right? So the hamburger menu, and I'm going to go to examples, right? So in the examples then, if you remember, right, you have the search box here, right? So we are going to do ESA, right? And now I can see the ESA notebooks here, right? So remember always that you got to click here in the middle of that, right? And not in the notebook itself. If you click in the notebook name itself, this link, you open it up as read-only, right? We don't want that. We want to copy and we want to be able to run it, right? So we click here, and then we're going to click Create Notebook. All right. So now with the Create Notebook, what we can do here is we can just say, OK. And then we get that notebook created for us. OK. Since we're here, I'm going to also create the other one. So I'm going to click here in the middle of that OML4Py feature extraction here. And I'm going to click on Create Notebook. Okay, so you can see that this one has the wiki model in the name, right? And then I'm going to click on the last one, the OML4SQL one, and then I'll click on Create Notebook as well. All right, so now we got those 3 notebooks created. I can go back to notebooks. So if I click on my hamburger menu and I go back to my notebooks here, okay, now I can see them here, right? So you can always click here in this little bar and expand to see the full names, right? So it's a good idea for you guys to look at that. So as I mentioned before, we're going to start with this guy, right? This is the OML4Py feature extraction ESA, right? So not the wiki model. So the difference here is because these guys use the wiki model, they're only going to run and work if you actually have the wiki model imported into your autonomous database, right? Or your on-premise database. All right, so ESA for text analytics, right? So the idea here is that we're going to create an OML4Py proxy, right? ESA model object, right? But this is not in this specific notebook, but we're going to be seeing some of these examples, right? All right, so the one that uses the Wikipedia model then. basically what we're doing here is there are a few things that we have to set, some specific policies that we are creating here. Okay, these policies are things that you have to create, like to create the index and the preferences that you have to create for using text mining, right, with Oracle database, with Oracle machine learning, right? So what we're doing is here is with OML4Py, right? We start with in OML4Py, we start with the cursor, right? So we get a cursor, and then basically we can just send any, right? We can execute any SQL, right? Against that session. So with Python here, then we're running these specific commands, right? So we're running some PL SQL against that to, drop references and drop the policy, because we're going to create a new wiki lexer preference, right? And we're going to be calling it basic lexer, and we're creating basically a few of these, and then we're going to create a new policy name, right? So these are just because we have already preloaded the our model, right? Our Wikipedia model, and we have links here in this guy so that you can go and see where the Wikipedia-based cognitive models are available, okay? And then we can check on the using the pre-built Wikipedia-based topic model. That's the blog post. If I'm not mistaken, this might be the older post. We got to check, right, Sherry? I don't think this is is this the one pointing to the latest one? Let me see here. Yeah, this is for the previous one, right? That's for the previous one with version 12, right? But in any case, the process here is the same, right? So we're going to have to do an OML ESA, and then we're going to say model name equals, and then you got to give it the name. So when you import that Wikipedia model, you're going to have to give it a name. So there's got to be, a name that you give that model object when you load it. So in this case, we're going to import OML, and then this is the name we gave it, right? Model name equals wiki model. Okay, so let me start by running this guy here, and now I can run the second one here. Okay, so I can see that I have that model down here. Okay, what's happening is you guys might not, and that's the thing. If you guys are following along, you might not have the model name right on your own OML that has that name, right? Wiki model. So this is how the wiki model is, right? So I loaded this guy and that date, right, at that point on my database. Okay. So what this guy will do then is I'm going to create a proxy ESA model object for it. So when I can do this, right, OML ESA, and then I create a model name equals, okay, and then now this model contains the ESA model object, right? Now this model is huge, right? So if I get the, I can get the features, right? So in this case, because you might have more than that, with the ESA wiki model features, you're getting the top 1,000, right? So we're getting just a little piece of all the different features that are in there, right? And there are many, many, many rows. So you can see that by doing a head 1,000, I'm only exploring the first 1,000 records. I don't really need, it doesn't matter if I do this, because Zeppelin is going to limit anyway the amount of data that it can show to 1,000. But you probably don't want to, keep streaming the rest if you don't need it, right? Because you're not going to be able to see it anyway. So Zeppelin might be saying, okay, let me wait, because I'm going to show you the first 1,000, but if your model is bigger, it's going to keep coming, right? So I'm doing a head 1,000 here, and I'm doing a round so that we can see the coefficients, and you can see the words, right? So these are all the different features, right? IDs are there, and then attribute names, right, and attribute values. So you can, I can scroll down, and you see all these attributes, right? So you can see all on the left-hand side, right? This very strange feature IDs, right? Not very nice. But in the left-hand side, you're going to see all the different things, and then you see the attribute names, right? So basically, that's the entire a part of that, right? The top 1,000 or 1,000 of these dictionaries, right? Of these components. So on the right-hand side here, if I check the set parameters, right, it's going to just show me the model. So it's going to tell me, you know, this is the model. It was built using the explicit semantic analysis, right? These are the items, and the missing value was automatic. There was a disable for the sampling. There are 200,000 max text features, right? This version had at around 200,000. The version that is there now, the latest one, has 161,000, I believe, because they were able to extract even more information and get it a little denser. And then basically that's the idea here, right? So you have the models and you know the same information, right? From Amr ibn Al to Zewin Sentai Kryoger. That's the last words, right, that you see there on that file, and it's 21 million records, right? 21,750,651, right? All right, so let's check some examples then. So how can I use that model, right? So to use that model, basically what we're going to do is going to say, okay, what does, you know, the word bank, right? If I take the word bank, what does that relate to using the Wikipedia model, right? So by using the transform, I can check what are the feature IDs that have, you know, the highest values here, right? So I say, okay, transform that guy here, right? So this is I'm creating a new a little view, right? With OML push, I'm creating just a little view or a temporary table, right, if you will, with this data frame that only contains this guy, right? Text bank. And now I'm saying, okay, now Wikipedia, please let's check what that content is. So what it's showing me here is what is the relationship between that word and the different concepts, right, that are available there. So you get back, you know, Banking of Australia, Bank of America, Central Bank, Bank Boston, Standard Bank, Commonwealth Bank. These are all related to the things that are there in the Wikipedia, right? And the ones that are most common, right, based on there. So now we can check the words NFL games, right, for example. So we say, you know, the text is NFL games now. So we can run and check a transform. So basically what it's telling me is what are the kinds of things that are related to the NFL games, right? So NFL International Series, National Football League, Thursday Night Football, NFL Network, history of NFL, NFL Christmas game, Super Bowl, right? So these are some of the things that are related to NFL, right? And on the right-hand side, you can actually remember that I mentioned, right? It's not only words, right? And you know, a couple of words. You have phrases. You can enter an entire text. So we're now passing on an entire text related to, you know, astronomy, right? So the important thing here is be careful with the parentheses, right? When you're using this, you got to be careful with apostrophes and things along those lines, right? You just watch out for those things. But now you see that you have like solar system planets beyond Neptune, planetary system, exoplanet, and things like that, which are related to what they're saying here, right? Appears to be a planet orbiting another star, right? So now we can do something like this, right? So nearly 70% of Americans say they're careful about the way they eat, and even more say diet is essential for good health, right? And then you can see here obesity, right? Because that was one of the concerns that you're mentioning here. Child obesity, healthy diet, health, you know, social issues, right? Nutrition. Again, that's the main idea, right? You pick the main idea and then you can start seeing these features. Now we get a much longer text here, right? Talking about stocks and, you know, the Fed and the periods and the economy, right? Central banks and the Ben Bernanke and all of these different things, right? European central banks. So you see Ben showing up here at the top, and then Mario Draghi as well, which was mentioned in the text, and recession, long depression, right? So that's the main idea, is picking up those right, that information. Now the cool thing with this, right, is perhaps not only using it by itself, but comparing strings. So now we're saying, okay, please compare street and avenue, right? So you get a similarity, right? 21% similarity here. Now compare street and farm, then it's just 1%, right? It's definitely very different, right? Now you can type in a little text like PGA Golf, right? Versus MasterCard Colonial Open, right? And you get a reasonable, 0.11, right? That means those two things are decently, have some relationship. But the thing is, if you do the same text about the PGA, and now you talk about the quarterback for the Denver Broncos, it knows that this is, golf and this is football, right? So it will show you that similarity is very, very low. Even though I did not say anything here about football, but it understands that because it sees quarterback, right? It sees Denver Broncos. So it will automatically do that, right? Adapt that for you. So, and then on the right, we have a very long text about NASA and SpaceX, and we want to compare that NASA Perseverance with the text about SpaceX, right? That's going to be delivering the segments of the Moon orbiting gateway, and yeah, it looks like it says, it makes sense, right? It has a lot of things in common here, right? And then finally, if you think about NASA rover and then Naomi Osaka, right, the tennis player, then it's going to know, yeah, that's very likely very, very small similarity, right? All right, guys. So that was what I wanted to show you in terms of the ESA. I will find out the other one reason why the other ESA is not here, because we used to have one that is with Wiki, one that is without Wiki. So somehow we named both differently, but we're showing the same data. So the one that says Wiki in the name actually does not have the Wiki in it. So if you guys want to test out how to create an ESA by from scratch, you can use this one. The one that says Wiki model is actually the one that does not have the Wiki in the name. And then you can check that we're actually building a model from scratch. So we're creating a text policy here from scratch, and then we're saying, hey, these are my this is my text policy, right? These are the comments, and when you add those things, you can create a very simple model. So you're building here a model, right, with some training data and the settings that you specified for text, and then here, we have just very simple attributes, right? Because that's what we created. So when you type in, these are the attributes we created. These are the corpus, right? This is the corpus of the documents that we created. Basically are these ones here, right? So we only fed it, 7 different components there, 7 pieces of text. So now it's anything that we ask it to do, it's going to be comparing those, with the 7. So things like, compare a word against those 7, the 7 components, and that's basically what it's going to be able to do, right? Compare comment A versus comment B, and what's the similarity, right? So that's the main idea, right, behind that. All right, so we're gonna make sure that we rename those models correctly, and that you guys can see them the next time you know which one is which. Okay, and finally we have the SQL version, the same thing, the PL SQL version of that, and this one is using the Wikipedia, so it shows you how to do it with PL SQL and SQL, for you guys to run directly against it. Okay. All right. So sorry that I went a little bit longer than I wanted.
Okay.
And how are the questions? Any questions?
I think we're pretty much caught up on the questions, and that I mean we had a good suggestion here for more best practices and real world examples. So I think that'll be something good to add as well. And a question as far as where is the data stored, or object store of the database, and that was that Sherry responded that the model's imported into model tables by the user to user mining models. So I think we're set on that. Any last questions from anyone? No? All right, well, thank you, Marcus. Great session.
Sure. Thank you, guys. We appreciate it. Talk to you later.